Evaluate each integral. In part A, we have integral, this elongated s dx. That's the notation for integration. Integration of x cube with respect to x. It's like x to the some power n, and we are using this power rule. Okay, integral of xn with respect to x is given by xn plus 1 divided by n plus 1, as long as n is not equal to -1. So this is 3, which is not equal to -1. So by the power rule, this is just x 3 plus 1, 4 divided by 4, and plus c, because when we differentiate this function we get x cube, and derivative of c is 0, and x cube is same as x cube plus 0. This is arbitrary constant, any constant. Now integral of ex, just ex, because the derivative of ex is itself, so antiderivative should be as well, same as well, ex and plus c. 1 over x, in fact 1 over x is same as x raised to -1, but for -1 this power rule does not work. There is a special power rule for that, and we know that derivative of natural log of x is 1 over x. So antiderivative, look at here, you're right. So antiderivative of 1 over x is natural log of x. Natural log of x, there is absolute value because natural log is defined for positive values only, plus c. Here we got a square root of x dx. Square root of x means x raised to 1/2. So let me rewrite this function, x raised to 1/2 dx. Now we can use the power rule, x and dx. Okay, x and dx, that is equal to x raised to n plus 1, half plus 1, 3/2 divided by 3/2 plus c. Or we can simplify this. There's 3/2, when we move, keep, change and flip, this becomes 2/3 on the front, times x raised to 3/2 plus c. Part E, similar to D, cube root of x squared. So let's get rid of this cube root. Then x raised to 2/3. This cube root means we need to put on the bottom, 2 already there, 2/3. Now this is like x n dx. So using the power rule, we get x raised to n plus 1. So 2/3 plus 1, that's 5/3. And same thing on the bottom, plus c. Now we can simplify. So when we take this to the top, 5/3 division by 5/3 is same as multiplication by 3/5, x raised to 5/3 plus c. Okay, f integral of nothing dx, that means here is 1. Okay, nothing means 1, and we know that derivative of x is 1, so just x. So integral of dx is x plus c. Integral of 0, and we know that derivative of a constant is 0. Okay, derivative of constant is 0, so constant plus c. C is also a constant, so constant plus another constant, we can just write one constant c. Okay, in fact this c is c, one constant plus c. Next, integral of 2, that's just 2x, because derivative of 2x is 2 plus c. Or we can refer to like f and h to this formula on your right. Integral of k dx is just kx, because derivative of kx is just k. Now here same thing, pi square. Okay, do not confuse this with a function of x. This is not a power function, this is not a function. Pi is a constant, it's a real number. more specifically it's an irrational number. Pi square is also constant. Okay, it's like some constant dx, so similar to h. Then the antiderivative is that constant x plus c, because derivative of this is this constant survives times 1, so just pi square. So this is similar to h. Same thing here, j. E cube, that is also a number. E is an irrational number, so e cube is also a number. So like I, then this is just e cube x. Okay, k, x to the n. Now power rule, this will be x raised to 99 plus 100 divided by 100 plus c. Okay, 1 over x to the fourth, so we need to get rid of this fraction. So this fraction is same as integral of 1 over x4 is same as x raised to negative 4. Okay, move this to the top, x raised to negative 4. Now this is like xn, so we can use the power rule. So antiderivative of xn is xn plus 1. Negative 4 plus 1, that's negative 3, divided by same thing. And we can simplify this negative to the front, and 3 on the bottom, that's 1/3. And okay, that's 1/3. X to the negative 3, negative exponent, if we put on the bottom here with 3, then that becomes x cube and plus c. Okay, m 3 to the x dx, this is an exponential function because x comes in the exponent. Look at the right hand side, we need to use this formula. Antiderivative of ax dx is just ax divided by natural log of that base a. Okay, because when we differentiate this we get ax. So this will be then same thing, 3 raised to x divided by natural log of base 3, done, plus c. And finally n, this is similar to m, but this is 5 times 2. We cannot multiply 5 times 2, but 5 can be pulled outside. It's just a constant, can be pulled outside. And 2 raised to x. Okay, these are different. So 2 raised to x. If we had 5 raised to x, then we could multiply and we would get 10 raised to x. But just pull 5 outside, 2 raised to x dx. 5 outside times 2 raised to x using this exponential function, or like m, we get 2x itself divided by natural log of 2 plus c. Final.